F. The sample mean for this data is less descriptive as the center of location than stream mean. Okay. Many students in our class have done this exercise. So some students have the same solution with Buổi, Nguyên Long. Some students are different. Who have any comment? If you have any comment, please write down on the comment box, please. In my grade, Cù Anh Minh, you haven't done the exercise. Đặng Thanh Hải, Đỗ Đức Toàn, Đỗ Mỹ Linh, Đoàn Tùng Dương, you haven't done. Lê Hồng Anh done the assignment. Nguyễn Hoàng Nam, Nguyễn Hoàng Nhật Quang, Nguyễn Ngọc Trâm, Nguyễn Quỳnh Trang, Nguyễn Thế Anh. The proportion don't do the exercise, you know that. You may be minus a lot or a point. We have a plus 5, a 3, and minus 2. When comparing with the other who turn in the exercise may be different, is 5 points. No? Yes, many students only view, not turn in. I accept some solution don't fool all the exercise. However, you must be turning. Okay, you see that many students, deliver the solution exercise to me. The other haven't. So please turn in your exercise. All students turn in. I will see and remark and give you point at the end of this course.
Excuse me, teacher.
Okay.
When I in last week I asked you apply my homework in a file or in photo, but when I apply, I use the collab file. Is right? Isn't allowed?
What's your name?
My name is Trần Thanh Hiếu. Because my camera is so bad, I only use color file.
Okay, I see. Let I check.
Yeah, the last.
You turn in.
Yeah, but I just use.
I know you turn in collab is okay. However, you have to say to me, okay?
Yeah. Okay. Thank you so much, teacher.
Okay. Oh, a lot. Let I check it. I have just downloaded a quick one. Oh, 10, no. 1 to choose one. Perfect. You have each exercise in one file. It's nice. Use the Python code. Very good. Here's the x sort, x green. Here's a sort green, and then plot it. Okay, nice. And exercise number 3. Here's no edging. It's here. Edging is here. Edging short, nor edging short. Green edging, nor edging short here. From this, you draw the picture. Draw the picture. The edging and nor edging. Okay, nice. The exercise number 4. Here's A and here's B. A short, B short, A green, B green, B, and plot A, plot B. Okay. Quite easy exercise with you. You see the exercise from here. Thank you. Let's check. Number 5. CG, TG, short, green, everything the same. And then draw the picture, plot CG and TD at the same time. 1.6. Temperature 20, temperature 40, short, and green it and plot it. Every exercise the same way. Where's the 7? No 7. Number 8. Big, mean, median, short, variance, standard deviation. Okay. Number 9. Mean of edging, no edging. STT variance. Because the statistic your friend use denote is STT. Number 10. A, short B, mean A, mean B, variance of A, variance of B. Okay. 11. CZTG, variance. Easy. 12. Temperature 20, 40, standard deviation of two sample. 13. X, sort X, and then find minute, median, a big. Okay. 14. X, minute, median, a big. Variance, standard deviation. 15, whereas 15 don't have a like exercise 7 and 15.
Because I just write in my notebook.
Okay. But your camera have a problem, so we can't deliver it to me, right?
Yeah, yes, sir.
Please take a photo, even that the quality of the image is not good. However, it's proof to me. It's evident. Show me that you do exercise. Okay.
Yeah, teacher. Yes, of course. I do it right now.
Okay. 16. Can't see it. 17. Smoke, no smoke. Mean, standard deviation, plot. Okay. 18. X, short x, plot x. Mean x, median of it, standard deviation. Eighteen here. $19. X, short x, plot x. Mean, median, and standard deviation. 20. X, short x, plot x, and median. 21. X, short x, mean, median, standard deviation, plot. Okay, nice.
Em yêu cô là em hoàn tác nộp bài để em nộp thêm ảnh nữa.
Okay.
Vâng, bởi vì em hoàn tác thì nó sẽ ghi lại là em nộp muộn. Em phải bảo cô.
No problem. Okay.
Vâng, vâng.
Mean, median, standard deviation. 23.
I like of them.
Okay. No
Best.
problem.
Yeah, thank you so much.
So you can see that the level of our exercise and the solution from here, and let's say here and Bùi Nguyên Long. You have seen that your friend done all of this exercise. It have the same pattern. If you can do one if you can do one exercise, you can copy the method the same with the other, right? So you have many ways to deliver your solution to me. You can use like Thanh Hiếu is the Python code, or you can write down in the notebook and give solution to me. Okay, it's like this. About the sample, I give to you in the theory section. So the other student who haven't give to he don't turn in the lesson, please do it in this week. 26, 27, 29, okay, 30. Everything is the same. Very good. So I finished the exercise solution here. Do you have any question for this? Please turn in. Because you don't turn in, you have to notice that the difference of turn-in student and the student don't turn in is 5 points. One pupil is a +5 and the other is a -2. I would like to check any question from you. Nguyễn Hoàng Nhật Quang, my computer is too early to download application to open file. Oh, really? You can use the web, the collab web. Yes, Dang Huy Hoàng gives you the solution. Open it in Google Colab. It's online. Don't need to download anything, right? Okay, I'm sorry, teacher. Last week I can't come into class because of failure. I will submit later. Okay, I accept it. I also did my homework in Python and Word. Very good. Sorry, teacher, I forgot submit. I will submit later. Okay, I have the sample mean is the same. Is the same. Okay, nice. Anyone have any comment? Please write down the comment box. If you don't have any comment, I will continue the theory section because last week, the first week, we have 1 hour to describe about the syllabus. So one part of definition probability I missed. So I want to finish the second week. I can complete all the knowledge to help you to understand and clearly about the probability definition. Okay, I can continue. Here is a definition of probability of event A. Have 3 axioms. The first axiom, for any event A, probability of A is from 0 to 1, or another word, probability of A greater than 0 and smaller than 1. And probability of sample space equal 1. And the third axiom, if infinite event mutually exclusive event, then probability of A1 union A2 union A3 union 3 dots equal probability of A1 plus probability of A2 plus probability of A3 plus 3 dots. So infinite event. Now it's still true with finite event. It is difficult for you. And how do you prove that probability of empty set equals 0? About the axiom, we don't have the accept that probability of empty set or null set equals 0. We have only three axioms. The first is here, and the second is here, and third is here. And now we have to prove that probability of empty set equals 0 and finite mutually exclusive event equal probability of each event. Now I change. Wait me for a moment. I change my event. Let I do it. Okay. Have you seen this? We have three axioms. Three axioms. First, for A is the event. For all the event, probability of A greater than 0, smaller than 1. Okay? The axiom 3 is the probability of sample space equal 1. And axiom 3 is A1, A2, 3 dots, is infinite event mutually exclusive event. What is a mutually exclusive event? It means that xi and xj equal null set for all the I different j. In the last hour, I said to you that is A1, A2, A3, etc. So all of them destroy or intersection equal null set. Okay, so probability of union infinite. You remember the infinite set equal sum of each event. Komarov only said three axioms here. Now we have to prove that we have the theorem. Sorry. Yeah. We have a theorem. Prove that probability of null set equals 0. How we prove it? It's A. We prove it. We consider A is not empty set. Okay, A is the subset of sample space. Any A, we choose the arbitrary A. So we consider A1 is A, A2 is empty set, I equal empty set for all the I greater than and equal to. Okay, so now we consider that AI intersection AJ equal empty set for all the I different J. Why? Because A1 equal A. Okay, or all the AI equal empty set that I greater than 2. So you see that A1 intersection for all the AI with I different one equal empty set. And AI and AJ that I and J greater than 2 always empty set. So we have A1, A2, infinite 3 dot here equal are mutually exclusive events, right? We use axiom 3, the axiom 3. The axiom 3 said to us that A1, A2, A3, 3 dots equal probability of A1 plus probability of A2 plus probability A3 plus etc. Right? And here we know that A1 is A and A2, A3, all of them equal empty set. Sorry, here's a union. Sorry, I am sorry for a moment. Sorry, I can continue. Union, right? A1 is A, union empty set always equal A. Okay, and here's the A1 equal A plus probability empty set plus probability of empty set and infinite. Okay, now probability A and probability A here to show us that here is a 0 equal probability of empty set plus probability of empty set extra infinite. From this, we see that probability of empty set small n equals 0. From this formula, tell us that probability, here's infinite probability of empty set or null set equals 0. Follow axiom 1. Where's the Asian one? It's here. For all the event A, probability of event A greater than 0. So probability of empty set equal greater than 0. Here's 1 and 2. From 1 and 2 toward that, probability of empty set must be 0. Okay, here's the proven. The theorem. The theorem, probability of empty set equals 0 with 3 axioms here. Now from 3 axioms here, we want to prove that we have the next theorem. The A1, A2, and AM, N, okay, are mutually exclusive event. We have proved that probability of A1 union A2 union AM equal probability of A1 plus probability of A2 plus 3 dot probability of AM. We change the axiom 3, the third axiom, infinite mutually exclusive event, to finite. Finite is n, and is smaller than infinity. Okay, now prove it. Now we choose B1, BI equal AI. BI equal AI for all the I from 1 to n. Okay, BI equal AI for all the I from 1 to n. BI equal empty set for all the I greater than n plus 1. So we have B1, B2, 3 dot, Bn. Bn plus 1, 3 dot infinite, right? And we see that all the Bi and Bj, Bi and Bj equal empty set, because Bn plus 1 equal empty set. Empty set intersection with any set equal empty set. And B1 to Bn is mutually exclusive. It means that B1 to Bn are mutually exclusive. So we have Bi intersection Bj equal empty set for all the I different j. You see? From this, we have that B1, B2, here's the infinite event, mutually exclusive event, right? We use the axiom 3. We have a probability of B1, union B2, union Bn, union 3 dot. Here's the infinite, equal probability of B1 plus probability of B2 plus 3 dot, probability of Bn plus probability of Bn plus 1 and 3 dot. Okay? You see this? From Bn plus 1 equal empty set, right? Equal empty set. Bn plus 1 equal empty set here. So the left-hand side, we have probability of B1, union Bn, union empty set, union empty set, 3 dots. Okay, equal probability of B1 plus 3 dot probability of Bn plus B empty set plus probability of empty set plus 3 dots, right? It's equivalent that empty set union with any set equals the set A union with empty set equal A. So here, the left-hand side, we have a B1, 3 dots, union Bn. Okay? Equal. The previous tell us that probability of empty set or null set equals 0. So we have it equal probability of B1 plus probability of Bn. Because from B1, B2 equal A1 union An equal probability of A1 plus probability of An. So from the three axiom, we have definition three axiom. We prove that the infinite in axiom 3, we reverse to finite event mutually exclusive probability of union of n and mutually exclusive event equals sum of probability of each event. Okay, and you can use two theorem. Don't need to prove it. We can use this and use it. This theorem in your exercise. You need to prove it. Okay. If you understand, please write down on the comment box. It means understand. If you don't understand, please write down N on your comment box. I will illustrate more. Trần Thanh Hiếu, you write down D. What does it mean? U, it mean understand. N, it mean not understand. If I see many people not understand, I can continue illustrate. The other student, I have received about the 30 students. We have more than 30 students. Okay, I see that only one student don't understand clearly. Please ask your friend. And I can tell you that what is probability? Probability is a map from the sample space probability is the map from sample space S to the interval 0 and 1. 0 and 1. Each event A from sample space have one value PA in the interval 0 and 1. Here's a map. Map you study that is the each object we have the number probability A in the interval 0 and 1. So the source set is the sample space, and the another set is the interval from 0 and 1. Each event A from A, we have one value probability of A in the interval from 0 to 1. Here is the definition probability. And probability must be satisfied three axioms. Probability of A greater than 0 equals 0 and small n equal 1. Probability of sample space is 1, and we have three axioms here. And we prove that probability of empty set equals 0. We consider A1 equal A, and from AI equal empty set for all the I greater than 2. So we use axiom 3. We have a union here. We know that A1, A2, infinite are mutually exclusive, so we use axiom 3. We have a probability of union event equal probability, sum probability of each event. So we can change like this. From this 0, we limit probability of A, so 0 equal that. From this, we see that probability must be smaller and equal 0. Axiom 1 tells us that probability of empty set greater than 0. From 1 to we have proof probability of empty set equals 0. The next theorem, from infinite, we have to group the finite event mutually exclusive. We have this formula. Now we assign BI equal AI for all for I 1 to n. BI equal empty set for all the I n plus 1. So B1, Bn plus 1, etc. Mutually exclusive event, right? Use 3 axiom 3. The sum of infinite equal probability of each event because they are mutually exclusive. Use axiom 3. From this, we transform B1 to Bn empty set equal probability of B1 to Bn, and sum up here. Because probability of empty set equals 0, so we have the probability of the BI plus Bn. Now we transform BI to AI. So we have proven. Thank you. I have illustrate again. Do you understand?
Yes, of course. Thank you so much, teacher.
Okay, nice. Now I change to our textbook. Now we have a 10-minute break. We have a 10-minute break. back, please. We have just finished 10 minutes. Now we continue. Toss. A coin is tossed twice. What is the probability that at least had occurred? We have a sample space, have 4 outcomes. And if the coin is balanced, each of these outcomes is equally likely to occur. So from this, probability of each outcome in sample space equal 1.4. So probability of A here, we have a head, tail, and tail head. So probability of A equal 3/4. We have finished the example last lesson. Now example 2.25. A die is loaded in such a way that the even number is twice as likely to occur as an odd number. If E is the event that a number less than 4 occur on the single toss of the die, find probability of E. The sample space of S equals the set from 1 to 6. We assign a probability W to each odd number, and a probability is 2W to each event, even number. Okay. Since the sum of the probability must be 1, so we have 3 plus 6, W equal 1. So W equal 1/9. Hence, probability 1/9 and 2/9 assigned for each odd and even number. Even is 2/9, sine 1/9, and probability of odd is 1/9. And E here smaller than 4, right? Less than 4. So it's 1, 2, 3. 1 is 1/9. 2 is even, so it is 2/9, and 3 is 1/9. So probability of E here is 4/9. I illustrate more. Here, you see that probability is a map from sample space to the interval 0 and 1. Okay? From this, in this example, the sample space is 1, 2, 3, 4, 5, and 6. Okay? Now probability is the map from each event in sample space. Is here, is A. We'll have the probability of A in the 0 and 1. Okay? Now we consider S here. Have 1, 2, 3, 4, 5, and 6. Now if the map is the responsibility 1 to 1 point in 0 and 1. Now from 1 to 1 over 9. Okay, 2 here, 2 over 9. 3 is 2 over 9. 4 is 1 point. Is a 4 is 3 is 1 over 9. Sorry. Have only 2 points. 2 over 9 and 1 over 9. 2 is 2 over 9, 3 is 1 over 9, 4 is 2 over 9, 3 is 1 over 9, and 6 is 2 over 9. And here's a B. The map from each element in sample space. We have one value in the interval 0 and 1. It satisfies probability of each A greater than 0, smaller than 1, right? It's true. Probability of X equal 1. It's true? Yes. 3, 1 over 9, and 3, 2 over 9, so it equal 1. It satisfies the second axiom, the first axiom. Now the third. Here we have a infinite, however, here we have only 1, 1, 2, 3, 4, 5. We always have that probability of each event of union of event equal probability of each event for all the AI. Some probability of AI for all the AI, right? I from 1 to n. So it satisfies the definition of probability. So this map is probability. Now we consider probability of E. E here's a 1, 2, 3. So it equals probability of 1 plus probability of 2 plus probability of 3. 1 equal 1 over 9, 2 equal 2 over 9, and 3 equal 1 over 9. So probability here equal 4 over 9. Okay? This dice is not fair. The even is greater than odd. Dot. Do you understand? This example 2.20. If yes, please write down you on the comment box. Okay, nice. Now we move on to the example 2.26. Example 2.26, let A the event that an even number turn up, and let B the event that a number divisible by 3 occur. Find A union B and A intersection B. A is the event that even number turn up. Even that is 2, 4, 6. And B is the divisible by 3. So we have two outcome is 3 and 6. Now we have to find probability of A union B. A union B is the outcome support for A or B. So we have 4 outcome, 2, 3, 4, 6. and A intersection B equals 6. From this, we find out probability of A union B. Here, the even is 2/9, and odd is 1/9, so it's 2/9 plus 1/9. 4 is 2/9 and 2/9, so it equals 7/9. And for the A intersection B, we have a 6. 6 is mean the probability is 2/9. Okay? Do you understand the theorem 2.26? If you understand, please write down on the comment box. It's U. If you don't understand, please write down N. Okay, move on. I see that all of you understand, and no one tell me that don't understand this example 26. So we move on to the another ruler. An experiment can result in any one of n different equally likely outcomes. Sorry. An experiment can result in any n different equally likely outcome. And if n of this outcome corresponding to event A, so the probability of event A equal probability of A equal n over n. It means that the number element of sample space is n, okay, big N, and the outcome corresponding to event A equals small n. And we need two conditions, two constraints. The first, n here is infinite. It's finite, n is finite. And the second, all the outcome equally likely. So the ruler 2.3, people call that the equally likely probability definition that you study in high school. However, now you go to university, you have another definition. It's the Asian probability definition. Replay for the ruler for the equally likely probability definition. Because the advantage of this definition is that the number of outcome of sample space is finite. And the second, all the outcome must be equally likely. This constraint is very strict. In the fact that many problems in our life, the outcome is not equally likely. And the second, we don't know that the number of outcomes is finite, right? Example, we consider how many how many customers go to a supermarket per day? We don't know exactly n, right? And how many people we withdraw money of a bank? We don't know. How many people will disease COVID today? We don't know too. So number n here must be fixed and finite. We don't know. So in many real life problems, people can't use this definition. And advantage of this definition, a probability of A equal n over n. You see that? It's very simple and easy to compute it. Okay, so the disadvantage is about the equally likely and n is finite. And the advantage is simple to compute and find out the solution. Okay, now the next example. A statistic class for engineers consists 25 industrial, 10 chemical, and 10 electronical and civil engineers students, civil engineering students. If a person is randomly selected by an instructor to answer a question, find the probability that the student chosen is A, an industrial engineering major, and B, a civil engineering or electrical engineering major. To do this, we have to denote event E, M, E, and C. The student major industrial, M for mechanical, and E electrical, and C for civil engineering, respectively. The total number of students class is 53, and here is 53, of whom are equally likely to be selected. Now A is we chosen an industrial engineering major. So here is the n, small n is 25, right? And so 25 of 33 student majoring in industrial engineering. So probability of I here equal n, small n is 25 over 53. Okay, so here's the probability of I. Now the next question, the civil engineering or electrical engineering. It means that C union E. C union E equal 18. We see that C is 8, right? And E for electrical is 10 here. So it equals 18 over 53. Do you understand this example? If yes, please write down U on the comment box. If you don't understand, please write down N on the comment box. Let's I check the understand example of you. Okay, I received many answers from you. Understand this. The next example, please read by yourself. Now we change to the additive ruler. If A and B are two events, then A union B equal probability of A plus probability of B minus probability of A and B. Here's A and B, and A union B is the blue state, right? So A union B equal probability of A plus probability of B, but we plus 2 times A intersection B, so it's minus A in intersection B. You see that? Here illustrate of proof. If A and B mutually exclusive, right? So A intersection B equal empty set or zero null set. So it equals 0. A union B equal probability of A plus probability of B. Now you can do by yourself the example 2.29 for 2 minutes, please. You read this example and do by yourself in 2 minutes. Example 2.29. Okay, I see the solution from Buổi Long. Probability of A and union B equal probability of A plus probability B minus A and B, right? So we see that probability of A equals 0.8, probability of B equals 0.6, and probability of A and B equals 0.5. So using this rule, additive rule of two events here, here. Additive rule, we have A union B equals 0.9. Okay, and Nguyễn Mạnh Thắng have the right, correct solution. From now general, we can use n mutually exclusive event, A1, A2, AN. So we have a probability of A1 union A2 union AN. It's three dots AN equal probability of each event. And the corollary, if A1, A2, and AN is the partition of sample space. Partition is strict more than mutually exclusive. You remember the last week I told you that partition is justified mutually exclusive and mutually collective adjunctive. Collective adjunctive. It means that union all here equals sample space. So from the corollary 2.2, we have a sum of probability of A1, probability of A2, three dots, probability of AN equals probability of sample space, so it equals 1. Now for three events A, B, and C, probability of A union B union C equal probability of A plus probability of B plus probability of C minus A and B minus probability of A and C and minus A, B and C and plus probability of A and B and C. Okay. Now we have another theorem. It's A and A prime are complementary event. Then A and A prime here is a partition. A intersection A prime equal null set and A union A prime equal sample space. So probability of A plus probability of A prime equal 1. So if you sometimes we want to find out probability of A, we can use the probability of A prime by this formula 1 minus probability of A prime. Okay, finish for this week. Goodbye and see you next week on Tuesday.
Goodbye, teacher.
Sorry, teacher. Could you can upload the answer to exercise 1 to up the my team?
Upload? What? I think that will give you the assignment quick 2. I will find the number of exercise of assignment week 2, and about all the assignment, all the exercise in week 1, you have to do by yourself or ask your friend. I give you the solution in the beginning of this hour. Okay. Goodbye.
Thank you. Goodbye.
Goodbye, teacher. Goodbye, teacher.
Bye.